Hi, so here is a quick demo of model construction specifying initial conditions and dynamic boundary conditions in Mechanica. So here you can see I'm already in IPython, and then I'll go ahead and load a model script here. And we can see that the entire script is literally about 7 or 8 lines of Python. So we can go ahead and run this guy. So we can see that the initial model, all it does is just randomly populate a cubic region with a random set of points. And that's great, but let's go ahead and do something more interesting. Let's go ahead and bind, using the built-in bind pairwise function, a potential to a set of particles within a certain radius. You can see when I first loaded the model, that object there, beads, that's actually a list of objects I made it. And we can see that method, it operates instantaneously. And what it did is it found all of the objects that are within a one length unit of each other, attached an explicit bond to each pair. So let's go ahead and run this and see what happens. So we can see that all of the connected objects will one tend to pull in towards each other because of that harmonic bond that's attached between these pairs here. So looking at the code, we can see it's plain old standard Python. We create a list of positions, and then using the standard Python list syntax, we call the bead constructor for each position in that list of positions, and go ahead and show the simulation. And the entire simulation runs real time at about 25 to 30 frames a second. So we have an entire running model in 10 lines of Python. Oh, and Loki says hi.